Hi, my name is Ounsinegad, and today we're going to be talking about the large white cabbage butterfly and parasitic wasps. To begin, the female large white cabbage butterfly releases an aphrodisiac into the environment around her in order to attract other male butterflies to come begin the reproduction phase. Once one male butterfly finds the female and begins the reproduction phase, it releases a chemical called an anti-aphrodisiac, which then deters other male butterflies. However, it attracts parasitic wasps. This provides a problem to the female because these parasitic wasps come and latch onto the female and lay their own eggs within the female's eggs. The goal of this project is to take the biological systems that we found and use mathematics to represent the biological processes that we see. This is used by using DE. As you see in this slide, we have the parameters as well as the differential equation model, which I will go more into depth in the next slide. So you see the yellow highlight, the green highlight, and the pink highlight. The yellow highlight shows the rate at which the population of butterflies is increasing. The green shows the death rate of both the butterfly and the wasp, and the pink shows the interaction rate between the anti-aphrodisiac, the butterfly population, and the wasp population. So this is how that bridge is formed between the two populations. So we took the model and analyzed it for long-term behavior in order to see what the different levels of anti-aphrodisiac could be. So to begin, we have the low level of anti-aphrodisiac, which shows that wasps aren't able to find much prey in the butterflies. This then kills off the wasps and allows the butterflies to go above their carrying capacity and slowly make their way back down to a flat line, which you can see in the graph right now. Then you have the high level of anti-aphrodisiacs. In this case, there's too much chemical released into the environment, so while it shows coexistence between the two graphs and most of the graph, it still varies widely depending on environmental issues. If an environmental issue were to occur, then both species would actually go extinct. Lastly, you have the healthy level of anti-aphrodisiac. Coexistence is present, but you see that little dip and then a flat line, which is where that coexistence is. Lastly, we have conclusions, which are that we found that the anti-aphrodisiac actually that's produced is 2 millimeters, and that allows for coexistence. And with that current knowledge that we've seen, that is actually how much, on average, a male butterfly produces. And some of our future work includes including more predators into the model, such as birds or things that eat the wasps or butterflies. We also want to include an equation that shows the relationship between the male butterflies and the eggs, because that is also present within the environment. Lastly, we want to provide the model with more variables that show accuracy for temperature and climate. Thank you.